Hey everyone, welcome back to your fourth section of Code in Place. I'm so happy to be back with you again after skipping a section last week. Today we're going to be talking about graphics and writing a program that uses the graphics library to draw shapes on our screen. Now that doesn't sound so exciting when you just describe it, but I think graphics programs are some of the most exciting ones to actually write because you get this visceral sense of your computer actually doing things and doing things that you can see pop up on the screen. A lot of the ways you've probably interacted with computers in the past, like playing video games or just looking at pictures and so on your computer, all operate on very similar principles to what we're going to be talking about in section today. I think this week's section is also a really good opportunity to practice some of the things we've been learning about in the last couple of weeks, like functions and parameters, and how Python really stores and represents information internally. I'm really excited to get started, so let's just jump right into it. Alrighty, so I want to start a little bit differently today. Rather than jumping straight into a programming problem, I want to start by doing a conceptual overview of how we reason about graphics programs, because it's actually a little bit different from console programs and Carol programs that we've been writing beforehand. So, somewhat ironically, I'm actually going to start by doing some drawing to make sure we're all on the same page as to how graphics programs actually work. Now, whenever we're drawing in real life, we need something to draw on. For example, right now I'm drawing my tablet over here, and hopefully you can see the lines that are showing up. Now, in exactly the same way, when we're doing drawing in a Python program, we also need something to draw on. Just like I'm drawing on my tablet here, or you may draw on a sketchbook or a whiteboard, in Python, we draw on something called a canvas. So the question becomes, in Python, how do we get a canvas? Well, it turns out that there is a function or a tool that allows us to do that. The line of code we use to actually create a canvas is this. We say canvas is equal to canvas, and then we pass in some parameters to this canvas over here. What are those parameters? Well, they're essentially how large we want our canvas to be. Now, when we're talking about computers and sizes, we usually measure dimensions in units called pixels, which are kind of like tiny little rectangles that make up your screen. You can't really see them on a laptop screen or a computer screen or a phone screen because they're so tiny. But for now, what I would like to do while we're going over this is pretend that each one of these squares over here is a pixel. So each of those tiny squares is a little bit of a pixel. And what's important about this is that any pixel can have at most one color. A pixel can be pink, or a pixel can be green, or a pixel can be blue. And certainly it can be other colors as well, but at a high level, we should think about the pixels as just being one color. So whenever we're drawing graphics on a computer, we essentially need to figure out how to set regions of pixels on our screen to be particular colors and particular shapes. Now, there's a lot of complexity that goes on over here, and fortunately, some of the Python tooling we're going to be using takes care of a lot of complexity for us, and I'll explain how in just a second. But before we get there, we should go back to how exactly we create our canvas over here. What goes inside these parentheses? Well, like I said, it needs to be the dimensions of our canvas. So in this case, let's say that I'm going to draw a canvas that is 10 pixels by 15 pixels. Just making sure I have enough space to actually draw it over here. Now, the first parameter over here is the height of the canvas. And the second parameter is the width of the canvas. So what this means is that we're going to be creating a canvas over here that is 10 pixels tall and 15 pixels wide. So let's go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Alrighty, so as exciting as it must have been for you to hear me count, here is our canvas. Now, what we're going to do once we have this canvas, and of course on our computer it's going to be a perfect rectangle, I just don't have a very steady hand, which is why I've got these little bumps over here. So let's go ahead and now think about what we can do on our canvas. Like I said, it's 10 pixels high and 15 pixels across. So what does this mean? It means that under the hood, we actually have a variable now. So we'll write that down, a variable called canvas, which sort of points us at this canvas object that we just created. This object is what we're going to be doing all of our drawing on. So what sort of drawing can we do on a canvas like this? Well, let's start by talking about some of perhaps the simplest shapes that we might want to draw. For example, a rectangle. Let's say I wanted to draw a rectangle that started at this corner over here and went down to this corner over here. The way I would do that is by doing, let's first draw that rectangle, and I missed the corner, but that's all right. All right, so here's a rectangle. Let's quickly resize it so it is at the correct corners. All right, close enough. So we've got this rectangle now that starts at this corner over here and ends at this corner over here. So what we need to do is figure out what the coordinates of that rectangle are. Now, specifically what we want to do is figure out two important coordinates on the rectangle. We want to figure out this coordinate over here and this coordinate over here. Because if we know those coordinates, then we know exactly where the rectangle is supposed to go. That's also the same as saying that we need to know what this coordinate is, which is a y coordinate in the vertical direction, and what this coordinate is, which is an x coordinate going in the horizontal direction. Equally, we need to know what this y coordinate is and what this x coordinate is. And we should give these things names so it's easy for us to reason about exactly what each of these coordinates are. So what I'm going to say is that this coordinate up here is the coordinate that is at, excuse me, not top, left x, top y. Essentially the x coordinate of the left of the rectangle and the y coordinate of the top of the rectangle. And equally, this coordinate over here is going to be right x and bottom y, because it is the x coordinate of the right side of the rectangle and the y coordinate of the bottom of the rectangle. Just as a reminder, in case we've forgotten some of the stuff we might have gone over in school, like I definitely did, this direction over here is what we call the x direction or the x coordinate, and this direction over here is what we call the y coordinate. Also, because it's going to be important later on, we should keep in mind that the top left corner of the canvas is the coordinate 0, 0. That's just something we decided, and it makes us easier to know where we have to count from. So for example, in this particular case, we have, let me just choose a color over here. We have this coordinate, which has an x coordinate of 1, 2 pixels and a y coordinate of 1 pixel. So what we can say is that this left x is 2 and this left y is 1. Now let's do the right x and the bottom y. So once again, we're going to have to count. So finding the right x, we have to count the number of pixels. 1, 2, 3, 4, 5, 6, 7, 8, 9. So our right coordinate is 9 and our bottom coordinate is 1, 2, 3, 4, 5, 6. 6. So now we know the sort of bounding coordinates of our rectangle. We know that it starts at 2, 1 and ends at 9, 6. So what we can do, therefore, to actually draw this rectangle in code is call the function canvas dot create rectangle. And then as parameters to that function, we pass in the 4 coordinates that we just found. We pass them in this order: the left x coordinate, the top y coordinate, the right x coordinate, and the bottom y coordinate. So what we're going to do is we're going to call the function with 2, 1, 9, 6. And again, let's close off the parentheses. And again, what we did is we took the left x coordinate and that was the first parameter. We took the right x coordinate and that was the second parameter. We took the right x coordinate, that was the third parameter, and we took the bottom y coordinate, which was the fourth parameter. Okay, so once we do that, we now have the rectangle. So I'm going to go ahead and erase these coordinates over here just so we can look at our rectangle more clearly. Oh no, I erased the rectangle. Let's try that again, shall we? Okay, and we can do the same thing over here. That t is going to have to stay, unfortunately, but that's all right. So that's how we draw this rectangle over here. One other thing we can do just for fun is we can add colors to the rectangle. So we can say, for example, the fifth parameter is a color red, and what that's going to do is that's going to actually fill this rectangle with a red color, which I think is kind of fun. So hopefully that gives you a sense of exactly how we should be reasoning about the sorts of things we need to think about when we add something to our canvas. We have to think about it in terms of coordinates. That is the coordinates of the left and top sides and the coordinates of the right and bottom sides down here. So exactly what does that mean now? What's interesting about this is that all we told the canvas was what the 4 coordinates were, as well as optionally what the color would be. The canvas then knew how to take those 4 coordinates and turn them into the rectangle that we actually saw on the screen. We didn't need to explain to the canvas, oh, draw a line from here to here, and then here, and then here, and then here. The canvas just knew how to do that. And that's something that's a really powerful tool to have. Simply that this variable over here, the canvas knows how to do a lot of things. We can give it information in the form of parameters, but it under the hood knows how to do a lot of these important things like drawing rectangles. Let's go over one other behavior that might be helpful for us, certainly will be helpful for us, I should say, in the problem we're about to do. So I'm going to go ahead and erase this rectangle over here. Let's see if I can do that without erasing the canvas as well. And yeah, all right, let's say now instead of drawing a rectangle, we wanted to draw a circle. So I'm going to go ahead and quickly do that. Let's say we wanted to draw this circle over here. And nice, that is a perfect circle. That's very satisfying. I do want to get the coordinates exactly right because that's going to be important. So here is a circle that we want to draw. Now, how exactly do we do this? It's not quite as simple as the rectangle case, or so it seems, because we don't have corners over here. We don't have a top left corner and a bottom right corner anywhere, because by definition a circle doesn't have any corners, and nor does an oval. So what we need to do is figure out some other way to specify where the circle should be. And there's a bunch of different ways you could do this. One of the ways that I think is natural to a lot of people is to say the center of the circle is over here, and the radius of the circle, or the width of the circle, the diameter, is this many pixels. And that's a totally reasonable way to think about this, but the graphics library that Python uses actually looks a little bit different and thinks about circles a little bit differently. The way it thinks about circles is by pretending there's a box drawn around the circle. So let's go ahead and do that. So we're going to do a dotted line around the circle like this. Okay, so this is what we refer to as the bounding box of the circle. That is the smallest box that fits totally around the circle. And just as an interesting detail, that means that the circle touches the box here, 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 and here. Now, maybe this is something you should pause the video to sort of reason about to yourself, but if we draw a box like this, there's only one possible circle we can draw inside the box that touches the box on each of the 4 sides, and that's this one over here. You should pause the video to think about that. It does sound maybe a little unbelievable at first, but I promise you it's true. But what I want to do now is say that now that we have this box over here, and we know that this box uniquely identifies exactly which circle we need to draw, or which oval we need to draw, we once again have a box that has coordinates or corners with coordinates. Here's one corner and here's another one. So just like a rectangle, I can say, okay, here's my top left coordinate and here's my bottom right coordinate. Draw a circle between these coordinates over here. And once again, we draw the circle with no problem. So let's go ahead and draw that now, or count that now. So the first thing we need to do, let's pick a color, is figure out this coordinate over here, which is left x, and that's equal to 1, 2, 3, 4, 5. And now we need to figure out this coordinate over here, which is equal to 1, 2. So we can say top y equals 2. And then I'm not going to draw the lines for the other ones, but we can count the coordinates together again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can say that right x is equal to 10, and one last count, 1, 2, 3, 4, 5, 6, 7, and bottom y is equal to 7. Okay, great. So we have our coordinates, and now it's just a question of knowing exactly which function we need to call to draw this circle. So again, it's going to be a canvas dot create, and now rather than it being create circle, it's create oval. And the reason for that is quite simple. The reason is just that an oval really is just a circle which doesn't have a square bounding box. If this square over here was a rectangle instead, we'd have an oval inside that rectangle rather than a circle. So let's go ahead and add our parameters. We now have left x first, which is 5, and then we've got top y followed by right x and bottom y. So that's 5, 2, 10, 7, and close off our parentheses. And once again, we've specified exactly where the circle should be on the canvas. The canvas is going to take care of all the annoying details, like actually drawing the curve and figuring out where it should touch the box and all those sorts of things. We just told the canvas, hey, here's the box that should contain the circle that I'm in. Once again, we can add another parameter, which would be the color. So we can say blue, and once again, we can color the circle blue, which of course I'm not doing very well, but you can imagine would be colored satisfactorily while the program is running. Okay, so now that that's all done, what we need to ask ourselves is, where did this canvas come from in the first place? What is this magic canvas function over here? Well, it turns out that what we're actually doing under the hood is we're using what's called a library in Python, which is essentially a set of functions and tools that someone else has written and that we can just use. Just like Carol was a set of tools someone else has written, but that we could use. So the way we get access to that library in Python is by writing a line of code that looks like this. From graphics, that should be an H, import canvas. So what exactly is that doing? That's saying that, okay, someone, in this case, the Code and Place team, has created this library called graphics, and from graphics, we want the canvas tool over here, which I apologize, this should be a capital C. And what that's basically doing is that's saying this canvas object over here is now available for us to use throughout our program. That object also gives us access to a bunch of other behaviors, such as create oval and create rectangle, which I showed you a little earlier on. So hopefully that gives you a sense for exactly how graphics program is supposed to work. Really, it's just a question of figuring out what you want to put on your canvas and where it needs to go. Now that we have that under our belt, let's jump into the section problem for this week, which is going to use a lot of these tools in a way that I think is actually kind of fun to watch. So with that, let's jump into the section problem. All right, we're back in the good old Code and Place IDE. So let's get started by going over the problem that we need to solve in this week's section. So we're going to be writing a program that solves a problem called random circles, which, as its name suggests, draws random circles. Now, there's a few things that are random about these circles. The first of which is they occur in random positions around the canvas, and also they have random colors. As you can tell, some of them are blue, some of them are cyan, some of them are salmon, apparently, looking at the color over here, and so on. So, what do we have available to us already? Well, looking at the problem description as well as the name of the constants over here, we have two constants, canvas width and height, which refer to the dimensions of the canvas. So you'll see that this is a canvas that's 300 pixels tall and 300 pixels wide. And also we've got constants called circle size and end circles, which, as their names suggest, refer to the size of the circle and the number of circles we need to draw. So I want to be clear about what circle size means. What it means is that each of these circles is going to be 20 pixels fully across, both vertically and horizontally. So more formally, for those of you who are mathematically inclined, what we're saying is that circle size should be the diameter of the circle, and therefore the width and height of the bounding box that surround that circle, just as a hint. So with that in mind, let's go ahead and indulge once again in my favorite programming pastime, strategic procrastination. So we do know for sure that once we've created our canvas, we need to actually call draw random circles on our canvas. And that should be, fairly clear that once we have a canvas, we actually need to draw random stuff on it. And if this program, or excuse me, if this function worked, then the program would work too. So what we need to do is make sure this function works. So we'll go ahead and say draw random circles and give ourselves a little comment. Draw n circles, random circles on the provided canvas. Now, I think there are two things we need to be able to solve in order to draw 20 or however many circles on our canvas. The first of which is we need to draw one circle. Draw one circle. And then the second thing, as obvious as it sounds, is we need to do that 20 more times. So this thing, oh, excuse me, not 20 more times, just 20 times total. So this part feels somewhat familiar to me. I kind of already know how to repeat things in Python over and over again, right? That's just the good old for loop. So for I in range, and rather than saying 20, I'm going to use the n circles constant defined up here. So for I in range n circles, we need to draw one random circle. So once again, let's pretend to draw one random circle works. And now what we're going to say, oops, I forgot the def, is draw one random circle. And let's just go ahead and print I am drawing a circle. Let's just run our code to make sure that at least we're getting to this bit over here. Go ahead and hit run, and there we go. We have 20 different I am drawing a circles showing up on our screen over here. So the question then becomes, how exactly do we draw random circles? Well, something tells me that somewhere down here, because we're drawing a circle, we're going to need to do canvas.createOval. And for now, let's just give it some random parameter. So we can say 0, 0, 50, 50. And I think it's always a good practice to make variables for our coordinates. So let's go ahead and do that. Left x is equal to 0. Top y is equal to 0. Right x is equal to 0. And bottom y is equal to 50. That should be a 50, not a 0. And now we can go ahead and swap in our variables over here. Left x, top y, right x, bottom y. Alrighty, so now we should have gotten a circle to be drawn over here. By the way, if you ever forget which functions are showing up or are available on the canvas or anything else, you can always go ahead and just click the docs button on the side over here. And that shows you a pretty exhaustive list of everything the canvas can do. So in this case, I'm using the create oval function over here, which tells us exactly which parameters are expected for this function, as well as how the function actually behaves. So let's go ahead and run our program and see what goes on over here. Run. Oh no, we have an error. So we asked the superhero what was going on, and we got an error saying that canvas is not defined. It says that canvas hasn't been defined yet, and we need to make sure to define the variable canvas before we use it in our code. Well, we do have a canvas variable, right? It's right over here, and we created it over here. So why is it not working over here? Well, this goes back to something really important that we've been talking about in the last couple of weeks of Code in Place, and that is function parameters. Why is it exactly that this function has canvas available, but this one doesn't? It's because fundamentally every function only knows about its own variables. So draw random circles has a variable called canvas, but draw one random circle does not have that variable. So why exactly does it not have that variable? It doesn't have it because all we've done is we've said, okay, the main function creates a canvas variable and then gives it to draw random circles, who receives it over here. But draw random circles needs to also give it to draw one random circle over here. And then we need to specify the name of the parameter over here. So take a second to pause the video here and really make sure you understand exactly what I did. It's really, really crucial. And random circles aside, probably the most important part of this problem. If you're still confused, I definitely recommend asking questions on the forum or watching the lecture videos again to make sure you understand this. Understanding parameters really unlocks a lot of how we write our programs. So now that our draw one random circle function does have a canvas variable, when we hit the run button, something should hopefully happen. And great, it did happen. So we now have a circle showing up over here. And you'll have to take my word for this, but this is actually 20 different circles. They're just all exactly on top of each other because they're all in the same place according to these bounds. So the question then becomes, what's missing? Well, there's a lot of things missing. We're not doing anything random yet, and we need to figure out how to do random stuff. But the other sort of more minor note is that we're not using the correct size for the circles yet. We've said 50, but we should be using 20 because that's the circle size. So rather than hard coding 20, I'm going to just use the circle size variable and stick it here and here. And now when I run my program, I should get a smaller circle, which actually, I don't know if it'll look like it to you, but on my screen looks a little bit like an octagon instead, but that's okay. We'll pretend it's a circle for now because I can't control that. So now we have a circle that is the correct size, but not necessarily in the correct place yet. And what do we mean by the correct place? We mean a random place. So let's go ahead and figure out how exactly we can get it to be random. I think essentially what we need to do is say, hey, the left x coordinate should be a random coordinate, and the top y coordinate should also be a random coordinate. So how exactly do we get random coordinates over here? Well, it turns out that we've also got access to another library, helpfully listed up here, that's called random. And what random does is it gives us how many functions that allow us to get random things. So for example, there's one function, and I'm going to put it in a print statement so you can actually see what it returns, called random.random. Random.random takes in two parameters, a lower bound and an upper bound. So for example, I can say that the lower bound over here is 42 and the upper bound is 128. And what random is going to do is it's going to return to us a random number in between 42 and 128. So let's go ahead and run our code. I'm going to remove the I am drawing a circle thing for now. Let's see what happens over there. And great. We'll see now that we actually have a bunch of numbers being printed out, each of which is different from each other, because this function is giving back a random number between this range every single time. And I'm actually pretty happy that one of these numbers, 128, showed up, because what it shows us is that this is actually an inclusive random, meaning that it chooses between 42 and 128 and could in fact give us back 42 or 128. So what does that mean? It means we could probably use the random.random function to actually give us a random coordinate for x and a random coordinate for y. So let's go ahead and do that. Let's say random.random, and down here, random.random. Okay, so the question then becomes, what two numbers should we actually put in our function? So for that, let's think about where our x coordinates can be between. So the smallest possible x coordinate is the number 0. That's at the very left side of the canvas. And the largest possible x coordinate is the one on the very other end of the canvas over here, which helpfully we know is canvas width. So we can go ahead and say canvas width over here. And equally, the y coordinate, which measures the height direction, will be between 0 and canvas height. Alrighty, let's go ahead and get rid of that print statement and run our program. And oh no, something's not gone right over here. So what do we think might be going wrong over here? Well, let's go ahead and print some stuff out. Let's go ahead and print our left x and top y, as well as our right x and our bottom y. Go ahead and run that code. And here we go. Here's something interesting. We're seeing that we have, for example, this circle over here, whose top left corner is at 7528, and whose top right corner is at 20, whose bottom right corner is at 2020, which doesn't quite make sense because the bottom right corner would be at 2020, somewhere around here, and the top left corner would be 7528, so somewhere down there. So somehow we flipped where our top left and bottom right coordinates should be. But also, somewhat interestingly, our bottom right corners are always 20, 20. So what are we doing wrong over here? Well, let's take a look at our right x and our bottom y. We're seeing that no matter where the circle is, the right x of the circle should be at x coordinate 20, and the bottom y of the circle should also be at y coordinate 20, which isn't quite right, right? Because we want the size to be not a position, but a width or a height. And so I think what we need to say is that the right x coordinate, because it has to be to the right of the left x coordinate, is going to be this many pixels to the right of the left x coordinate. So let's go ahead and try that out. Left x. And equally, this should be top y plus circle size. So what we've said now is that these coordinates, right x and bottom y, depend on left x and top y, which I think makes more sense because it means if the circle is over here, then its bottom right corner is over here. And if the circle is here, its bottom right coordinate is going to be over here. So with that in mind, let's go ahead and run our code now. Okay, cool. And we now have circles showing up on our screen. So exactly, you'll see that now they're in random positions and they're all the same size. So clearly the change that we made over here was the correct change to make because now our circles are showing up. We're not quite done yet because as you can tell, there's one very clear difference between what's happening in this canvas over here, what's happening in this canvas over here, and that is the colors. We don't have the correct colors, or in fact, any colors in our canvas over here. So how exactly do we resolve that? Well, you'll see that there is actually already a function that comes with the starter code called random color, which gives us back a random color. And so fortunately, this makes life really easy for us because what we can say is, okay, let's get a color from the random color function. I'll go ahead and delete these and pass that color in over here. Once again, we're going to run our code And now we have colors, which is kind of fun. So you'll see some of these are blue. In fact, quite a few of them are blue. Then some of them are darker blue, some are green and purple, and so on. We'll go ahead and run our code again. And every time we run it, you'll see different circles. So that's kind of fun. And that actually brings us to the end of the formal section problem over here. So I'd encourage you now to pause the video and make sure to review this code, because there's not very much code we've written, but it's quite dense and the concepts are really complex. So I'd really encourage you to make sure you can take this code and connect it back to what I was talking about at the start of the video to make sure you fully understand how our understanding of graphics programs translates to the program we've then written. Another really great way to practice this understanding is to try some of these extensions over here. So for example, no matter what, right now when we run our code, we always see exactly 20 circles on the screen over here. No matter what, they're all exactly the same size. And so we can think about how maybe we can change the number of circles we draw to be a random number, or how we can make sure that the circles are all going to be a random size just to make our program a little more interesting. One other slightly more advanced extension you might want to think about is you'll notice that some of the coordinates, or excuse me, some of the circles are actually kind of jumping off the end of the canvas. So for example, there's this circle over here, which is kind of jumping off the edge, as well as the circle on the bottom. So you can think about how you can write your program to maybe make those circles vanish. Alrighty, so with that in mind, great job again on completing another difficult section problem. I'm really excited to see what you do with these tools to build your own lovely graphics. And with that, we'll see you next week. Have a great weekend and week, everyone.